Today we're going to be learning about drawing lines of fit and what that looks like and how we can use those lines of fit to predict values that are not actually present in our original data set. So you need to be on page 531 of your workbook. And we're going to go about halfway down. Okay, so we have two objectives today. First one, we're going to use a scatter plot to draw that line that closely fits our data. Okay, we call that a line of fit or a line of best fit. Okay, and then the second thing we're going to do is use that line then that we drew in there to predict values that are not present in the original data set. So let's take a look at what that really looks like. Okay, so looking at this here, we have the data points already graphed here into a nice pretty scatter plot. Okay, they don't form a straight line. They do have a linear relationship, a linear association. We talked about that in the last class. Okay, so we can draw a line of fit in here. Okay, a line of fit is a line that goes through the center of our data and is very close to most of the data points. Okay, so most. What we try to do is get roughly half the data points above the line and roughly half below. Sometimes, it's not going to be possible to get exactly 6 points above, 6 points below. So we say it's roughly. Now, one thing to consider here is that I'm drawing what I think is the best line of fit. Your line of fit isn't going to be exactly the same as mine. That would be rare if it were. Okay, so we're all going to have different lines of fit. However, they should be in roughly the same place. And we should get roughly the same answers at the end when we're predicting. Okay, so just keep that in mind. Yours isn't going to be exactly like mine. Okay, so let's look at the next page at some of these different scatter plots and the lines of fit. Okay, so this one we have elephants, and we have their weight of the elephant and then the age in months of the elephant. Okay, so to draw this line of fit, we go roughly through the middle here. Make sure you're using a straight edge when you do this. Notice we did not have to start our line down here at the origin. It doesn't have to start there. So let's look then at the next one. So this one has ski resort attendance, and we have the number of visitors and how high the temperature is. Okay, so the line of fit here doesn't really go through the middle of the data. This is not a real good fit. If I wanted a better fit for this, my line would be somewhere closer down this way to where you have roughly half the points above, half below. Okay. Last example on this page shows a scatter plot of the hours of sleep a person gets and their score on the math test. Okay. So when drawing the line of fit, you'll notice out here is an outlier. If there's an outlier, you can completely ignore that. Okay? Ignore an outlier because as you learned with mean and median and mode, it really disrupts your data. So ignore the outlier. Okay. Other than the outlier here, we have roughly through the middle of the data. It even goes through some data points. That's a bonus. Okay, doesn't have to go through data points, but it could. So this is a pretty good line of fit here. Let's take a look then at drawing our own. Okay, so we have a table here, the number of hours people trained in a month and what their 5K race time is in minutes. The first thing we're going to do is construct the scatter plot. Okay, so we're going to plot our ordered pairs. Okay, so take a second and plot these ordered pairs you see up here. So the first one being 5, 41. You can pause the video here while you get these points plotted. Okay, now that you have your points plotted, so your data is now in a scatter plot, okay, let's see if we can draw a line of fit that goes roughly through the middle of these. Okay, so I'm going to try to draw straight here on my iPad. We'll see how well I can do. Okay. Didn't draw so straight, but hopefully you get the idea there. Oops. Oh boy. Let's see if I can get rid of that little guy there. Okay. So pretty much have a line of fit with kind of the same number above. I've got a few more above than I do below, but overall it's a pretty good line of fit here. So does there appear to be a linear association between the variables? Yes, okay. There is a linear association here. We drew that line. Now, do most of the points lie close to the line? Yes, that's good. So it's a good fit. Now, bonus question. Okay, what kind of association is this? So we know it's a linear association. This is also a negative association. You learned that in the last class. So the more time spent training, okay, the less time it took them to run the race. We're going to go on to the next page here. Okay, actually, I'm going to skip the check. So I'm going to the next page, 535. Okay, and we're going to talk about using that line of fit now. So the data here is already plotted, and it's showing us the distance traveled and the cost of an airline ticket. Okay, and in general, it looks like the longer the distance, the more expensive the ticket would be, which makes sense. Okay, so using that line drawn here, we want to know approximately if I go 1,300 miles, okay, what is the cost of an airline ticket? Okay, so notice they've drawn it in here in green. We went over to 1,300 miles, okay, and I go up until I hit my line. There's no data point there, but I hit my line. Okay, I hit my line at where Y is roughly $275. So I could make a prediction here and say that if I travel $1,300, I'm going to have to roughly pay 1,300 miles. I'm going to roughly pay $275 here. Okay, so that's making a prediction. So the first intention today was being able to draw that line of fit. Okay, now we're working on that predicting piece. Okay, so this one here, notice, great, it already has the line of fit here. It looks like a good line of fit. I have, about the same number of data points above and below the line. I want to make a prediction here. The height of a tree, if the diameter is 8 inches. So I go to my x-axis where my diameter is 8. And I'm going to go up till I hit my line, not till I hit a data point, till I hit my line. Boom, right there. Okay, and then I'm going to see what is that y value. Okay, the y value is 24. So this tells me if I have a tree with a diameter of 8 inches, okay, then I could expect a height of roughly 24 feet. Is it exactly 24? No, because I'm approximating with my line of fit. But I can make a pretty close prediction using this line of fit. I would like for you to take a second with your group here, look at the check, okay, and see if you can make a prediction. If a server has 225 tables in a week, how much money will they earn? So pause the video here, work with your group, and then come back in and check your answer. Okay, so if I go to 225 on my x-axis and I draw a line up and I hit my line right here, oh man, it doesn't hit exactly on a corner, so I'm going to have to do some approximating. Okay, so if I then draw as close as I can over here, it looks like, oh, it's more than 1,000. So I would say maybe roughly $1,050. Okay, if you were in that ballpark somewhere, Okay, it has to be more than 1,000, less than 1,125. Okay, so somewhere between there, then you would be pretty accurate with this. Okay, so now you're going to do some practice on drawing your line of fit. Remember, you're keeping roughly half the points above, half below. And then you're going to use your line of fit you drew to make a prediction